Hey guys, welcome to lesson 2.4, solving systems with matrices. So basically we can take a system of equations, which we usually solve doing elimination or substitution, and we can take just the numbers out front, so like 2, 6, and 16, and make them a row of a matrix. The first column will then represent x, the second one will represent y, and the third one will represent all of our whole numbers. Then we can solve using what are called row operations. These are basically anything that you can do to an equation normally. So first of all, you can multiply an entire equation by something. That's going to turn into multiplying an entire row by something. So pretty much the equations are just being replaced by rows. So you can multiply a row by a non-zero number. You can't multiply it by 0, otherwise everything becomes 0 and you get stuck. You're also allowed to add the two equations together. And since you're allowed to add, that means you're also allowed to subtract. So that's basically how elimination works normally, is you multiply these rows so that either the x's or the y's go away, and then you add them together. The third thing you're allowed to do that wouldn't make much sense up there in regular equations, but makes more sense in a matrix, is you're allowed to swap two rows. It doesn't matter which one is listed first, so if this one was on top, it would still be the same system. We won't use that operation as much. Mostly we're going to use a combination of these two things together at the same time, okay? And then what we're going to try and do with these row operations to solve it is get what's called reduced row echelon form. And the most important piece of reduced row echelon form is that this number right here becomes a 0. Okay, and that's what we're going to do as our first step, is try and get that 0. Then the second thing we're going to do is, if this number isn't 1, we're going to divide so that it becomes 1. And that's what it's talking about in the second step. And the reason why is because now, if I were to write the equation for the bottom row, it would be 0x plus y equals 3, or just y equals 3, which means you already have y, and you can plug it back in to find x either into the top row or into any of the equations you started with. So like you could do 2x plus 6 times 3 equals 16. That's a possibility to find the other variable. Okay, and then I'm going to change something about these steps right here. I'm going to change each row to just row 2. So divide row 2 by its leading entry. Leading entry just means the first non-zero number. So you want to make sure that that's a 1. Okay, it sounds fancier than it really is. All right, let's get going and try some. One thing we're going to do really quick is this should be -3 and not -10. It should be very similar to this problem. I accidentally copied this one twice. We want that one to be a -3. So we are going to write an augmented matrix, which is just a fancy way of saying write the matrix for it. So you just turn all your coefficients into entries. Make sure you put them in order. So 8, 14, 4, top row, -6, -7, -10, bottom row. And then wherever the equal sign is, that's where we put the little bar. That's just our way of saying my variables are on the left, my equals answers are on the right. Now, we want to try and get this one right here to be 0 by adding these together. So basically we want to make the things on the far left cancel. It's the same thing as just saying we're going to eliminate x every time. So what we're going to do is try and get these two numbers to be the same but opposite signs. So we need a number that 8 and 6 both go into, which is 24. So I basically want this one to become 24 and this one to become negative 24. To turn 8 into 24 by multiplying, because we're allowed to multiply a row by a non-zero number, and then we're going to add these together. I need to multiply by 3, because 8 times 3 is 24. And I need to multiply the negative 6 by 4. It already has the negative, which is why I'm making it the negative 24. Otherwise, I could pick whichever one I wanted to. Then I have to finish the row. I have to finish multiplying this entire row by 3. So 3 times 14 and 3 times 4. And then negative 4 times 7, negative 7, and 4 times negative 10. And then I'm going to add these together. So that's what I mean by we're combining, adding them, and multiplying them, both of these two things. So now when I add them, I get the 0 I wanted to. That was the whole point. 42 minus 28 is 14. 12 minus 40 is negative 28. And this is going to become my new row 2. So the top row doesn't change. We will almost never change the top row, unless you want to swap them. And then I need to do my last step, which is divide row 2 by its leading entry. That's 14. So I need to divide this by 14. And what I'm going to do is write that answer underneath. So 14 divided by 14 is 1. Negative 28 divided by 14 is negative 2. And then I'm just going to do that. We're just going to replace it right there. Okay, we just replace it by dividing by 14. So now, if I read the last row, it's 1y equals negative 2. So I already have one of my variables. All I need to do is plug it back in to either one of these equations to find x. I'm going to choose the top one just because it's right there, easy to find. So instead of y, I'm going to put in negative 2. This is me replacing this y with negative 2. And then that's negative 28. So I can add 28 to both sides. And now I'm going to divide by 8. I'm going to write my answer over here. 32 divided by 8 is 4. And I wrote that really fast, so let me go back. 14 times negative 2 is negative 28. So I'm left with 8x minus 28 equals 4. Then I need to add the 28 to both sides. 4 plus 28 is 32, and only that 8x is left. 32 divided by the 8 is 4. So my answer is x equals 4, y equals negative 2. All right, let's try one more. Make it into the matrix first. Be careful. If you miss a negative or something like that, it makes it more difficult. Okay. On this one, I'm going to show you guys something that helps, and that is look across the rows and see if there's something you can divide them all by to start with, because we know how to divide pretty easily, and it makes everything else later easier. So for instance, I could divide these all by 2, and I can divide these all by 5 in the second row. This is the same thing as multiplying by 1/2. This is the same thing as multiplying by 1/5. So if we're allowed to multiply, we're technically allowed to divide the entire thing also. So if I divide all of these by 2, I end up with 1, 4, and 3, which is so easy to do. And dividing these all by 5, I end up with -1, -4, and -3. What this does is it just makes your matrix easier to work with. Because if you look, then you can just add those two rows together. Okay? And I'm sorry about that. That looks like 43. It is not 43, it is 4, 3. So I get 0, 0, and 0. Sorry, I know that 0 was a little weird in the middle. So, well, that's weird. What's happened now is my bottom row is 0, 0, 0. Well, that means 0 equals 0. I have nothing left. My equal sign goes right here, and 0 does equal 0. But since there's no variables left, we either have infinite or no solution. Since this is true, we have infinite solutions. 0 does equal 0. Okay, 2 more on the bottom, and then I'll talk about the special cases. So here, I'm going to do this the same way that I did this one up here, because the only thing that I changed was that I want this to be a -3. Okay, so I'm going to multiply, let me set up the matrix first. 8, -6, 14, -7, 4, -10, -3. Look at that, I made the same mistake. I'm just going to cross it all out and do that. So, I'm going to multiply this one by 3, and this one by 4. 8 times 3 is 24, 14 times 3 is 42, 4 times 3 is 12. -6 times 4 is -24, -7 times 4 is -28, and -3 times 4 is -12. So I'm not overly explaining this one. I multiplied this one by 3 to get 24, and this one by 4 to get -24, so that they add to 0. It's the same exact reasoning I did it up here. It's almost the same problem. The only number I changed is this one right here. Because now I get 14 and 0. And I wanted to talk to you guys about this without giving you a whole nother problem. So now my matrix is top row stays the same, and then 0, 14, 0. When you start having zeros, this line becomes more important. Because right now it says 14y equals 0. And if I divide by 14 on both sides, I get y equals 0. And then all I would have to do is plug in 0 for x. 8x plus 0 equals 4. Okay, I'm not going to show 14 times 0 right now, because that's just 0. So 8x equals 4. Divide by 8 on both sides. X equals 1/2. 4 divided by 8 is 1/2. And that's your answer. The last case that has a bunch of zeros is the no solution one. Here's what those look like when you're solving. First, let's set up our matrix. There it is. And then this one's already -3, so that means I would want this one to turn into 3. So first of all, I don't need to change anything about the top row. If your brain needs to multiply by something, just say you're multiplying by 1. But then this one, to turn -1 into -3, or to +3 by multiplying, you need to multiply by -3, so that these two negatives cancel out and become 3. And then that makes the next one -3, and -3 times 3 is -9. So now I have 0, 0, -5. Keep the top row the same. And the bottom row technically now says 0 equals -5. That's not true. That's false. So there is no solution. Alright, so be careful when you see a lot of zeros. I'm going to show you really quick an example of infinite and no solution, just so you have a way of comparing them. 1 second. I'm going to write it down and then leave you guys with this last slide because it'll be easier for me to explain. So whenever there's a lot of zeros, it's kind of hard to tell the difference between them. I'm including y equals 0 as a special case because people get it confused since it also has a lot of zeros show up. So when I say x, I really mean a non-zero number. I'm just using that as a placeholder. I don't mean like the variable x. I mean, this could be 1, 2, 3. These could all be different numbers. So if the bottom row is all zeros, that's infinite. If the bottom row is all zeros except the very last one, this is saying 0 equals whatever that number is, which is not true, like this one, where that x was -5. That's no solution. And y equals 0, which is a solution, it just happens to be 0 as the answer, is if it's 0, a number right here for y, like this, and then 0. So you can kind of look, all zeros, infinite. A number for y, but not zeros on the rest, is y equals 0. And all zeros except for the answer means 0 equals -5, which is not true.